Hey everyone, I'm having a difficult time finding a quiet place today, so I apologize. You're going to probably hear my dogs in the background. I even tried to sneak down to my daughter's room and they found me, so I apologize. Today we are going to be talking about adding and subtracting rational numbers. So we've already done adding and subtracting. The difference between what we were doing and now is we're adding in more rational numbers, and that means fractions and decimals. Yay! So I know some of you still cringe when you hear fractions and decimals, but really it's not that difficult. And I think that you are going to be very pleased actually how easy this comes to you. So the first one, and remember we are being critical readers. Suppose the 7th grader's birthday is today and she is 12. So that's an important number, 12. How old was she? Sorry, I cut off the word old when I was making this. Old 3.5 years ago. So this hopefully logically makes sense to you. So if she's 12, 3.5 years ago, how old is she? So we have to take away 3.5. Now on a number line, we have to go all the way up to 12. So here's 10, 11, 12. And then we have to take away 1, 2, 3, and a half. So 3.5 is exactly halfway in between 9 and 8. So she's 8.5 years old. Now what that equation is going to look like is how old was she, so what is her years, if we start at 12 and we add to that, I'm going to write it two different ways. We subtract 3.5, but remember what we learned in the last lesson. We have to add the additive inverse. Add additive, that makes me think of adding the inverse opposite. We're adding the additive inverse. So we had to go a positive 12 and then a negative 3.5. We could also show this on a vertical number line. So we haven't been talking a lot about that, but in many cases, especially when we're dealing with sea level or above sea level, below sea level, it helps to do this vertically. So we were at 12 and we went down 1, 2, 3.5. So we're still at 8.5. So this is what I'm dealing with right now. Instead of just leaving me be, the dogs have found me and they are trying to get things on the floor like Kleenex and socks. Nice. Okay, for this next problem, I don't have a word problem. Many times word problems, it's difficult to find whether you're supposed to add or subtract, but we just need to get the idea of adding or subtracting without having to decide which one we're supposed to do. So we're just going to practice with some rational expressions. So first we have to look at our problem. Negative 2.5 plus 5. And what we're hoping is that we are going to get to the point where we don't have to use a number line, but we have number lines available for you. So you're going to find that negative 2.5. So here's 1, 2.5. So draw your negative 1, 2.5. So it's going to be right there. Negative 2.5. And then from that, you're going to add 5. So here's a half. And I'm going to go, so that's 1, 2, 3, 4, 5. So here was 1/2 to 1. So I'm going to do this different. So because we started at a half, when we go 1, we're going to be at a half. So here's 1, 2, 3, 4, 5. So plus 5. So I'm at a positive 2.5. Or again, we could do that on a vertical number line. We started at negative 2.5, and we went half, so whole, another whole, another whole, so that's 3, 4, 5. So we went up to 2.5. All right, let's practice some without a number line. So complete the indicated operation. So there's just addition and subtraction in this first part, but again, we have rational numbers. We need to remember integer rules, so we are going to rewrite any subtraction to addition by using the additive inverse, but then we also have to remember how we add fractions. We have to change them to improper, change to common denominators, and then follow the integer rules for finding the answer. So let's try this first one. So first I'm going to change to adding the inverse. So adding the opposite. And then I'm going to change to improper. So here, the biggest mistake that is made is thinking that when you do 2 times 5, it's 2 times a negative 5, and then plus 1, but really this is a sign of the whole thing. So your answer is going to be, or sorry, once it's an improper, it's going to be a negative. And we just do 2 times 5 plus 1 is 11, and then our denominator stays the same. So negative 11 halves. Now it's plus 8. But remember, our 8 needs to be in halves. So if we change this 8 to something with 2 in the denominator, we have to multiply the 1 by 2 to get 2, so we have to multiply the 8 by 2, so we end up with 16 halves, and 16 halves is the same thing as 8. So we change to improper, we change to common denominators, so now we're going to follow the integer rules. I really like to, and I apologize, I'm using blue and orange. I really like to circle my numerators because my denominator I know is going to stay 2. And now I have negative 11 plus 16. We learned before that it's like these two do battle, and so we have negative 11, we have 11 negatives, and they take out 11 of these positives, so it's like subtraction, and we are left with 5 positives standing. So when in doubt, write it out. You could have written out 11 negatives and 16 positives, but when they do battle, we're left with 5. 16 minus 5, sorry, 16 minus 11 is 5. So what we found out last week was that when we have opposite signs, we subtract and take the sign of the greater. So now we have 15 halves, sorry, 5 halves, and that's a positive, and so we can change it to 2.5. All right, let's try another one. I'm going to change my colors. So here I have an addition sign, so I don't have to change anything. A very common mistake is always changing the sign to its opposite, but you only do that with subtraction. Only rewrite subtraction problems. So this is addition, so we're going to leave it negative 6 plus. Then we're going to change to improper. So 5 times 4 plus 1 is 21 fourths. Now they're not like signs, so we need to make them like signs. Sorry, they're not like denominators, so we're going to make them to like denominators. So we need to take our 6 over 1 and change it to something that has fourths. So 1 times 4 is 4, so 6 times 4 is 24. So now we have negative 24 fourths plus 21 fourths. And I like to circle my numerators because my denominators are going to stay the same. Negative 24 plus 21. Opposite signs, we subtract the absolute value and take the sign of the greater. So negative 3/4. In other words, if these negative 24s went to battle with these positive 21s, these 21 positives would cancel out 21 of these negatives, and we'd be left with 3 negatives standing. All right, let's try one with a decimal. So again, rewrite any subtraction to adding, and I again put multiplicative inverse, but really it is, I love multiplicative inverse, but that's the same thing as reciprocal. What I meant to say was additive inverse. So additive inverse. So that's when we're dealing with subtraction. We change it to adding the opposite. Keep, change, change. Keep, change, change. So we keep the first number, change the subtraction to addition, and change the second number to its opposite. Now, remember when you're adding or subtracting decimals, you line them up. You line up the decimals. So this is like 7.0 plus 0.9. So we end up with a positive 7.9. Next one. I would like you to try to do this one on your own. This one is, I believe, just very logical. Hopefully, if you have 2.5 and you know you take a half away, you can do this without too much thought. So pause and see if you can do this one. Okay, I ended up doing this one by changing my negative 1/2 into a decimal so I could see what they meant. If you have a decimal and a fraction, you're going to either have to change both into fractions or both into decimals so you can take away from each other. So I had 2.5 plus a negative 1/2. Because they're opposite signs, I had to subtract. There's more positives, so I was left with positives left over. All right, so let's start looking at some applications. It says to create an equation, or an expression really would work, and a number line diagram to model each answer. So first you have to write down what you're doing, and then you have to actually do it. So I would like you to pause and try these two on your own. Remember, this is your video. You're trying to get the most out of this learning experience, so pause the video and try these two on your own. All right, for the first one, Samantha owes her father $7. So if you owe, you're in the negatives. So -7. And she got paid $5.50, and she gives that. How much does she still owe? So of that -7, we're adding a positive $5.50 because we're paying back. So this is the equation. And so to show that on a number line, we start at -7 and we go a positive 1, 2, 3, 4, 5.5. So right there. Or if you wanted to show this with just the arithmetic, they're opposite signs, so you subtract. So 7.0, we line up our decimals, minus 5.5, and we do the subtraction. And so I end up with -1.5 because we still owe, she still owes the dad $1.50. And on the number line, that's exactly where we ended up, $1.50. All right, the next one. At the start of a trip, the car's gas tank contains 12 gallons. During the trip, it consumes 10 1/8 of a gallon. So we know we have to take away that. But when we take away, what we're really doing is adding the opposite. So now we have this fraction. So we have to keep the 12 for right now, plus negative. We have to change this into an improper. So 8 times 10 is 80, plus 1 is 81. The denominator stays the same. Now we need to change into like denominators. So I need to change that 12, and I always do this off to the side, 12 into something that has 8. So I know we're going to multiply by 8, so I ended up with 96. So I'm going to rewrite this problem. 96 eighths minus or plus a negative 81 eighths. Remember, I like to circle what I am doing so I don't get clouded by the other stuff. So my 8 stays the same in the denominator. 96 plus a negative 1. Opposite signs, I subtract. So 96 minus 81 to get 15. And then there are more positives, so if these two went to battle, 81 of these negatives would take out 81 of the positives, but we would still have 15 positives left over. So that means my answer is 15 eighths, or if we put it into a mixed number, 1 7/8 positive. All right, last one. So let's try to get the important information. A fish was swimming at 3.5 feet below the surface of the water. So because we're going below and above, anytime it's above and below sea level or temperatures, I always use a vertical. So this is my sea level. So this is the surface of the water. And it was 1, 2, 3, 4. It was -1, -2, -3. So it was -3.5 feet because it was below the surface. So here is where it started at 7 a.m. 4 hours later, it was at a depth of 5 1/4 feet below. So it's at 3.5 right now. We have to go to, it was 5 1/4 feet below where it was starting at 7 o'clock. So the question that's being asked is really important. What rational number represents the position of the fish with respect to the water surface? So we want to know how far down is it at 11 o'clock. So it's not saying what is the difference between where it was at 7 and where it is at 11. It's saying where is it based on the water surface. So from this 3.5, we're going to go down. So this is 3 1/2 below. We're going to go down another 5 1/4. So this was 4, 5, 6, 7, 8. So now we went down. This was 3.5. 1, 2, 3, 4, 5, which would put us at, let me just change colors here. So at 5, if we just went down 5, it would put us, now remember all of these are negative numbers, it'd put us at -8.5 if we just went down 5. But we went down another quarter. So I'm going to go from that 1/2, I'm going to go down another quarter. So 1/4 of the half. So I'm at -8 3/4 compared to the surface area. Now, another way to do that is we started -3.5, and we added to that another 5 1/4. So again, we have to change into improper. So 2 times 3 plus 1 is -7/2, plus 5 times 4 is 20, plus 1 is -21/4. And they're not like terms, so I'm going to take my -7/2 and I'm going to change it into something with fourths. So I have now negative 14, because 2 times 2 is 4, so 7 times 2 is 14, negative 14 fourths plus negative 21 fourths. Now, this is the first one today, I think, where we had two negatives. Negative plus negative, they're on the same side. They're not battling each other. They're on the same side. So if you have negative 14, you add another negative 21. So if you have 14 negatives and you add another 21 negatives to the battlefield, you end up with a negative 35 fourths. And if we change that into an a mixed number, 4 goes into 35 8 times, which is 32, with 3 left over. And I did not forget to carry over my negative. They were negatives, so here's a negative, and I have my answer as a negative. So whether we did it with the number line or just using what we know about rational numbers and integers, we ended up with the same thing. All right, so please start your assignment and let me know if you have questions. Those of you that are very, very good at fractions probably won't have as much difficulty, but make sure you check in with me often. All right, we out.